Okay, J2, elastic collisions, part 2. So now we're ready to do the case where before we have M1 moving to the right at speed U1, and then we have mass 2 moving to the right at U2. Now for a collision to take place, U1 has to be faster than U2 or greater so you can catch up to the other ball, or U2 here can be negative and it's going to the left. So either of those cases would work. And then for after, we'll have M1 traveling to the right at V1 and M2, well, we don't really know it's traveling to the right. We're setting this up as positive. In other words, we're setting up our problem where when you go to the right, it's positive. But if the masses are such that this V1 comes out to be negative, it just means it bounced. It's going back the other way. So we're setting things up where the positive is to the right. All right, so you want to start this problem off with the U2 being negative. That means this mass is moving to the left, and you would just pick U2 be some negative value of kilometers per hour or meters per second. So to the right is positive. So the equations now, well, you got two terms for the momentum on the before case. We have each mass with its respective velocity, the product, and then afterwards, M1 V1 plus M2 V2. This is conservation of momentum, all right? So conservation of momentum gets us this equation. Then, because it's elastic, we have conservation of kinetic energy. And that will give us 1/2 M1 U1 squared plus 1/2 M2 U2 squared is 1/2 M1 V1 squared plus 1/2 M2 V2 squared. And when I have pairs of equations, I always like to bracket them off like my friend did in grad school. So my convention is U stands for velocity before, and then V, which comes after U in the alphabet, is after. I prefer this rather than putting V everywhere and then having to put V sub initial 1, V sub initial 2, and then V sub final. I'd rather use U and V and just have one subscript. Now, this looks like a mess. The last section, it took us a while. The last section, to derive the result. So the result that we did last section, where U2 is equal to 0, we found V1. I'm just copying this down from the last section result. We had the difference over the sum times U1. And then for V2, we had twice the first mass over the sum U1. So this is what we got when we had U2 is equal to 0. That took a while. Now I'm lazy. I'm thinking maybe I can guess the answer. Because if I did the problem, suppose I did the problem, okay, so this is U1 not equal to 0, U2 is 0. Suppose I did the problem where U1 was equal to 0 and U2 was not equal to 0. In that case, U2 would have to be traveling, to the left to having a collision. But, we keep the signs, positive going to the right, like this in general. And the algebra will tell us that, or input will give us that. So if we did this, we simply exchange 1 and 2. So we would get then V2 is M2 minus M1 over, this would still be the sum because it's a plus sign, and this would be U2, and this over here would be then V1 because we're just swapping the subscripts 1 and 2, and this would be 2M2 over M1 plus M2, and this would be then a U2. Now I'm going to boldly claim that the general case, I'm going to add these. All right, so I'm going to claim that V1 in the general case, these are the ones that have V1. So I'm going to add these. Okay, here we go. We got this over M1 plus M2, U1, and then here plus 2M2 over M1 plus M2 times U2. And then for the general case with V2, adding these together, we'll take this one first up there. We have 2M1 over M1 plus M2 U1. Just simply copy that right here. And then I got to here copy the other one for V2, which is this part here. So that would be M2 minus M1, that one there, over M1 plus M2, and there's a U2 down there. So for the V1, you take this V1 and this V1, stick them together, and then for V2, you take this V2 and this V2. And I boldly claim that these are the general cases, and it turns out that they are. That's a clever use of symmetry to arrive at the answer. But it might be a good idea to work it out and get some algebra practice, algebra city. So that's what we're going to do. We're going to work it out. So we start then back with these equations up in here. And if we start with these equations, let's go back up in here in this pair. We have M1 U1 plus M2 U2 is M1 V1 plus M2 V2. And then here I'll multiply through by 2. So I have M1 U1 squared plus M2 U2 squared is M1 V1 squared plus M2 V2 squared. And what we did last time is we brought to one side one information and two information on this other side, before and after. So if we do that, we'll have M1. I will subtract, then it'll be U1 minus V1 to get the ones on the left, and I have to subtract this, bring this on the other side of the equation. This would be M2 V2 minus U2. So let's just check that. So M1 U1, if I subtract to get the ones on the left, I subtract the V1, and then here I have M2 V2, but subtract the M2 with the U2 to get the one on the right. So I'm going to do the same thing here with the next equation. So I would have M1 U1 squared, minus V1 squared. And then over here I would have M2 V2 squared, that's this one, and then subtract the U2 squared. So what we do is we have in other words, we have information for the first mass on the left and information of the second mass on the right. Then we can do the trick we did last time, where if you have a squared minus b squared, you can write that as a plus b times a minus b. So the first equation is not going to change. That's going to be the same. But the second equation will change. We'll have M1, and now we'll have the sum and difference. The sum says U1 and V1, and the difference. Then that's going to equal M2, we'll have the sum, V2 plus U2, times the difference, V2 minus U2. And these are the pairs of equations. Now we'll do the same trick we did last time where we said, well, let's look at this here. You got an M1 here, you got a difference here, get something extra, all right? So we have this extra part there. Now on this side we have an M2 and we have a difference. But then we have this extra thing here. So the reds must be equal. These extra factors must be equal. So U1 plus V1 equals V2 plus U2. Now I'm going to have this written as U1 minus U2. I'm going to bring the U's to the left and then bring the V, all the V's to the right. So this is V2 minus V1. But this profound equation, here I'm moving to the right in general here, and this is moving to the right. This is my approach velocity. But see, here's V2. After the collision, V2 is taken off, and then I subtract my speed. That's our separation. So we have the same rule that we had before, that the velocity of approach, go back up here, here you have U1, and you're subtracting this speed, and just think of this speed being less than this speed so I can catch up with it. That's going to be my velocity of approach. If it's negative, well then the velocity of approach is greater because, you know, coming at each other. And then here, you're taking V2, that's leaving me, and subtracting my speed. That's how we're like spreading apart. Separation, velocity. So that's still the case. And the first problem we did in the last section, we had U2 to be 0. And this is like the generalization of the velocity of approach equals the velocity of separation. So what we want to do now is define what V1 and V2 is. And what we're going to do is use this equation. I think the simplest thing is to use this equation solve this equation, solve this equation for V2. In other words, V2 is equal to U1 minus U2 plus V1. By simply bringing the V1 on the left-hand side of the equation. Then what we can do is take this V2 and put it in there. That equation looks simpler than all this stuff. And then solve for V1. All right, so that's the logic. So if we do that, this equation here becomes M1 U1 minus M1 V1, and that's going to be equal to M2. And here, this M2 is going to be hitting this first, and then minus M2 U2. So let's do that. M2 times U1 M2 times minus U2, M2 times V1, and then M2 U2 with the minus sign. So we go ahead and check these. The left-hand side, M1 U1, and then the minus sign, M1 V1. Left-hand checks. Right-hand side, M2 has to hit the V2, all this first. So M2 U1 minus m2u2 plus m2v1, and then minus m2u2. So we're good. So we want to solve for v1. So we're really after this. What is v1? So that's what we want to basically isolate here, and there's one over here. So we need to get the v1s together. So let me do that by writing m1u1, and let me bring this to the other side where the other v1 is. So this would be m2u1 minus m2u2, and now here we go, plus this one comes over here, so we have m1 plus m2 v1, and this is then minus m2u2. So we check this one is here, and we're going to bring this to the right hand side. So here that survives there, and then we bring this over. That one survives too. And then we bring this over, we have the sum of the masses times v1, and then this last one's hanging around. So everything is looking good. All right, so let's say here we have m1u1, and let's subtract here m2u1, and let's then add, we're cleaning up the right hand side, m2u2, and then we'll add this one, and then that's going to be m1 plus m2 v1. We're basically isolating this term here. We want to isolate that. So on the left side we have m1u1, subtract the m2u1, add the m2u2, and then add the m2u2. Look, there's two of them. That's nice. There's two of those. There'll be two of those there. And here, this looks interesting. This is m1 minus m2 u1. So we have it. v1 is equal to m1 minus m2 over m1 plus m2, because we're going to divide, so u1. And then here we'll have plus 2m2. We're basically dividing by the sum of the masses. And if we divide by the sum of the masses, we're going to have the difference over the sum plus the 2m2 over the sum, and here's a u1 and then a u2. Guess what? That's what we guessed. That's what we said it would be, by symmetry and by cleverness. We wrote down the answer without doing all this stuff here on the right-hand side. Isn't that cool? Well, are you ready for a little more algebra? So we do V2 the long way. So how do we get V2 the long way? Well, what I'm going to do is take my V1. I'm going to take my V1 and stick it in there. So my V2 is equal to U1 minus U2 plus V1. And that's the V1. So here, V2 will equal, now when I bring this in, I'm going to have a U1 piece. Let's go ahead and check those here, a U1 piece. And we're going to have a U2 piece. So that means for the U1 piece, I'm going to have 1, and then I'm going to add this, plus M1 minus M2 over M1 plus M2. And then for the U2 part, I'm going to have a minus 1, and then I'm going to have this, 2M2 over M1 plus M2. All right, let's check that. So the U2 is going to be a U1. There it is, the U1. But it's also going to have a U1 part from the V1 when you add it. So I just added that there and factored out the U1. There, the same thing. And then I'm going to have a U2 at a -1 plus the U2 part coming from the V1, which is just copied it down. There it is. So now we do common denominator, M1 plus M2, M1 plus M2, plus M1 minus M2, and then common denominator here, M1 plus M2. We have minus M1 minus M2, because of the minus sign, plus 2M2. So what do we have here? The M2s are gone, so we have 2M1 over the sum. Here, we have a 2M2 minus M2, so we'll have a minus M1 plus an M2 surviving over the sum. And this is going to be hitting the U2, and this thing is hitting the U1, and there's a plus sign. But if you look at this, this is what V2 is, and let's compare up here. 2M1 over the sum, hit the U1, and then here M2 minus M1 over the sum. I got it, like that's it. So I wrote this down using the symmetry argument that saves the time of doing all this calculation. Although this is good for us, gives us training, and we do the problem in 2 ways. So that is good. So before we leave this section, what about the baseball where you hit the ball that's moving at you? So in other words, U1 is greater than 0, that's the bat, and U2 is less than 0, it's the ball coming in to be hit. So if that's the case, we then use this formula. And with this formula, we just remember that the bat is a lot bigger, massive than the ball. So that means you could throw away the ball, and you're going to have the bat is going to continue with U1. That's what we had assumed. We'd thrown away the ball. The ball's 0. In other words, taking M2 to be 0. So M1 is so large, that gets thrown away, and you get V1 is U1. What about the ball? What's the ball do? Well, if the bat is very, very massive, you can then throw away this ball, and then hey, you get the 2U. Remember we talked about that, the 2U, the double. But what about over here? You get to add something here, 2U1, and you get the 2U1, which is basically the ball taken off at twice the bat speed, but you get more. You have more, because the ball's coming in now. The ball's coming in. So here, since the mass of the bat is so large, we can throw away the mass of the ball, and that's minus U2. But remember, U2 is less than 0. It's coming into the bat. So this is the more general formula that you get. If you just simply toss the ball in the air, just let the ball be there where U2 is 0, then you get the result we had last time, where when you hit the ball takes off at twice the speed of the bat. But this is a more general situation.